this is the last lecture of our chapter retaining wall. So students, in this chapter there are two types of retaining wall. First one is cantilever retaining wall and second one is counterfort retaining wall. So students, in the last 7 lectures we are discussing about the cantilever retaining wall. So there are mainly total 7 steps in which our first 6 steps are completed in the design of cantilever retaining wall. So students, in the last step we are discussing about our design of shear key. So students, after completion of the design of shear key, we are starting our example number 2, which is the design of counterfort. But in the design of counterfort, we are discussing about what is the main difference between the design of cantilever retaining wall and design of counterfort retaining wall, and those portions which are similar that not covered in our session. Okay, so in the counterfort retaining wall and in the cantilever retaining wall, the main difference is in the calculation of preliminary dimensions, and all the remaining steps are as per our method which is discussed in the cantilever retaining wall. So in the 7th step we are discussing about the design of shear key. So students, what is the dimension of shear key? The dimension of shear key is 0.45 meter into 0.5 meter. So in the the size of shear key is 450 cross 500 Okay. Now, what is the main function of shear key? The main function of shear key is to restrain against the sliding. So, our sliding force is acting as horizontal force. Okay. So, we have to provide it minimum steel in the shear key. So, our minimum steel is 0.12 percentage of total gross sectional area. Now, our AST required is PTBD upon 100, in which what is the value of capital D? Because in the minimum reinforcement, we have to provide it total gross sectional area. So, our value of capital D is 450 because our force is acting like this. So, this dimension is 450 So, this is the value of our capital D. Okay, so our AST required is 540 square. Now you all know that half of the main reinforcement of stem are anchored in shear key. So we have to provide a total 3142 square in the design of stem. So what is the value of half? The value half is 1571 square. So you all know that our minimum AST required is 540, but there are already 1571 square steel is coming from stem. So no any extra steel provided in the design of shear key. So you can see that this is the detailing of cantilever retaining wall, in which you can see that this is our shear key. So our reinforcement is continue in the shear key. So you can see that this is our stem portion, in which the vertical portion is our main steel and this dotted portion is our distribution steel. So you can see that this vertical portion, in which we have to provide it 20 diameter files at 400 center to center, and in point, it means in our whole pointed reinforcement is our distribution steel. So in the distribution steel we have to provide it 10 phi at 130 center to center. This is our toe slab. So in the toe slab portion, our uplift pressure is our net pressure diagram. So we have to provide it only at the bottom portion, and at this portion, this is our heel portion. So you can see that in our heel slab, our net pressure is in downward direction. So we have to provide it our main steel and distribution steel on the upward direction. So students, this is the end of our example number 1, which is the design of cantilever retaining wall. Now we are moving further to our second type of retaining wall, which is the counterfort retaining wall. So now let us start our example number 2, which is the design of counterfort retaining wall. So the question is, design and detail counterfort retaining wall for the following data. So the data is angle of repose is equal to 30 degree. Unit weight of soil is 16 kilonewton per meter cube. Height of wall above ground level is 7 meter. Safe bearing capacity of soil, it is also called as SBC, is 150 kilonewton per meter square. Our coefficient of friction between the base and the soil, it is denoted by mu, is 0.6, and use M20 and Fe415. So this is the data given in the question. So students, you can see that this is our counterfort retaining wall. So what is the difference between cantilever retaining wall and counterfort retaining wall? So the main difference is, in the counterfort retaining wall, this extra structure is provided with the help of concrete. Okay, so this is the counterfort. So these two counterfort, the distance between two counterfort is considered as L. Okay, so this is calculated in our step number 2, which is the calculation of preliminary dimensions. So now we are moving further to our solution of example number 2. So students, our step number 1 is to find out coefficient of earth pressure. So there are two earth pressures. First one is active earth pressure and second one is passive earth pressure. Now, what is the equation of active earth pressure? The equation of active earth pressure is 1 minus sin phi divided by 1 plus sin phi. Now, what is the value of phi? Phi means angle of repose. So, the value of angle of repose is 30 degree. So, after putting the value of phi, we will get our answer Ka is 1 by 3. Now our second unknown or second coefficient is Kp. Kp means coefficient of passive earth pressure. So you all know that your active earth pressure and passive earth pressure is inversely proportional to one another. So our value of Kp is the inversely proportional to Ka. So the value of Kp is 3. Now we are moving further to the very most important step, is the preliminary dimension. So students, this is the last step of this chapter. After that, all the steps are remain same as cantilever retaining wall. So our gamma, so the value of gamma, it means the unit weight of soil is 16 kilonewton per meter cube. Our SBC is 150 kilopascal. It means 150 kilonewton per meter square. So first of all, you can see that this is our ground, and the height above ground level of soil is 7 meter. So first of all, we have to find out the minimum depth of foundation. So our minimum depth of foundation is denoted by D minimum. So what is the equation of D minimum? The equation of D minimum is Q0 by gamma in the bracket Ka square. This bracket portion is equal to the coefficient of active earth pressure, which is denoted by Ka. Okay. So students, what is the value of Q0? The value of Q0 is 150. The value of gamma is 16. And what is the value of K? The value of K is 1 by 3. So After putting all this value, we will get our answer 1.04 meter. Now, in your book, you can see that your value is 1.04 meter. It means you have to provided minimum depth of foundation is 1.04. So you have to provided your foundation depth is higher than this value. So in your book it is provided by 1 meter, but it is not correct. You have to provided more depth than required. So in this example, we have to provided depth of foundation is 1.1 meter. Now this height is 7 meter and this height is 1.1 meter. So what is the total height of retaining wall? The total height of retaining wall is 7 plus 1.1, which is equal to 8.1 meter. Now, after finding out the total height of retaining wall, now we have to find out base width. So, in the cantilever retaining wall, the equation of to finding out base width is under root 3f upon 2 gamma. But in the counterfort retaining wall, it is directly given as your width of base slab is considered as 60 to 70 percentage of total height of retaining wall. So 60 percentage, it means 0.6 to 0.7 h. Now what is the value of h? The value of h is 8.1. So we have to provided our base width in the range of 4.86 to 5.67 meter. Now, in this between value, we have to assume that we have to provided our value of B is 5 meter. Now, after that, we have to find out this width of base slab. So what is the equation of width of toe slabs? So the equation of the width of toe slab is B by 3. Now what is the value of B? The value of B is assumed as 3 meter. So sorry 5 meter. So 5 divided by 3 is equal to 1.66 meter. So we have to provided the width of toe slab is 1.70 meter. Okay. So if we have to provided our width of toe slab is 1.7 meter, then the relation between the base slab and toe slab is 1 by 3. If you have to provided 1.7, then you have to provided your base slab is minimum 3 times the 1.7. So we have to finally provided our width of base slab is 5.2 meter. Okay. So this is the calculation of the width of base slab and width of toe slab. After that, we have to find out the thickness of base slab. So you all know that in the cantilever retaining wall, the thickness of base slab equation is h by 15 to h by 12. But in the counterfort retaining wall, the equation is changed and it is h by 20 to h by 15. So what is the value of h? The value of h is 8.10. So 8.10 divided by 20 to 8.10 divided by 15. So you have to provided your thickness of base slab in the range of 0.405 to 0.54. So in this example, we have to provided our thickness of base slab is 0.45 meter. You are also provided this thickness of slab is 0.5 meter, but you have to make sure that you have to provide it in this range. Okay. After that, we have to find out spacing between counterfort. It is denoted by L. So this equation is 3.5 into h upon gamma raised to 0.25. So 3.5 is constant. What is the value of capital H? The value of capital H is 8.1. Now, what is the value of gamma? The value of gamma is 16. So students, after putting all this value, we have to use our spacing between counterfort is 2.95 meter. But in the book, it is clearly mentioned that provided center to center spacing between counterfort as 3 meter. But you can also provided this center to center distance between counterfort having less than value 2.95 meter, because if you have to provided your counterfort at closer spacing, it takes more strength. But one disadvantage is the cost is remain high. Okay. After that, we have to find out the thickness of stem at bottom. So this is the thickness of stem at bottom. So what is the height of stem portion? So the height of stem portion is total h minus 0.45. So it is 7.65 meter. Okay. So students, what is the value of force? The force means UDL. It is load. So we have to find out pressure first of all. So the equation of pressure is K into gamma into H. So after putting all this value, we will get our answer 40.8 kilonewton per meter square. But what is the unit of UDL? The unit of UDL is kilonewton per meter. So we have to multiply this value with 1 because we have to calculate all the loads per meter length. Okay. So this is 40.8 kilonewton per meter. Now you can see that this is your fixed support and this is also your fixed support. Now the distance between two counterfort is 3 meter. It means there are two fixed support having UDL and the length is 3 meter. So what is the value of bending moment? The value of bending moment you have to already use in your fixed end moment FEM WL square by 12. So the equation of maximum bending moment is WL square by 12. So after putting all this value, we have to find out our answer is 30.60 kilonewton into meter. But this moment is unfactored moment. So we have to find out factored moment. So our factor moment is 45.90 kilonewton into meter, and after that all the calculations are remain same, like we have to find out small d. So this is the equation for Fe415, that mu is equal to 0.138 FCK BD square, in which we have to find out your value of d. It is equal to 128.95 mm. But this value is very small, so we have to provide it 2 times then the answer. So we have to provide it our small d is equal to 257.90 mm minimum. So our final answer is 300 mm, but this is our small d. Now what is the value of capital D? So our capital D is 300 plus 50, which is equal to 350 mm. So you can see that this is our 350 mm, this is our 0.45 meter, sorry, this is our 1.7 meter. Then we have to find out our width of heel slab, which is equal to 3.15. Now, what is the width of stem at top? The width of stem at top is 0.2 meter. And what is the size of shear key? The size of shear key, as usual, the width of shear key is same as the width of the stem at bottom, and its height, it means its thickness, is similar to the thickness of base slab. So students, our provided shear key size is 0.35 to 0.45 below the base of the retaining wall to prevent sliding of the wall. So students, this is the end of our step number 2, and after that we have to find out stability checks, design of stem, design of heel slab, design of toe slab. So all these steps is remain same as the design of cantilever retaining wall. So you have to prefer this video, not you have to prefer your Atul Prakashan's book. Okay. So this is the end of today's session. Thank you.